You know that feeling, right? That knot in your stomach just before a deployment. The one where you're terrified that one tiny manual step, one wrong command could just bring the whole thing crashing down. Well, today, we're going to turn that deployment anxiety into deployment confidence. We're taking a journey from those painful manual processes to a super slick automated workflow that lets you ship code without breaking a sweat.
Look, if you've ever felt a little pang of guilt over your deployment habits, you are definitely not alone. Manually running SQL scripts, FTPing the vendor folder to the server, hard-coding secrets? Come on, we've all been there. It's kind of like the secret handshake for developers who've lived through the old ways and just know there has to be a better way.
And this just lays it all out, doesn't it? On one side, you've got total chaos, manual, repetitive work, the classic finger-pointing between the dev and ops teams, and secrets scattered through the code like little time bombs. But on the other side, you have the promise of DevOps, automation that just gets rid of human error, a culture where everyone works together, and these powerful, automated pipelines that make deploying code, well, kind of boring and predictable, which is exactly what we want. So here's the most important thing to get. DevOps isn't just some shiny new tool or a fancy job title. It's a real cultural shift. It's about building a mindset where developers and operations teams are on the same side, using automation to tear down the walls that slow everything down. The whole goal is to make releasing software a complete non-event. And a huge part of this is GitOps, this idea that your Git repository becomes the single source of truth for your app and how it gets deployed.
So here's our game plan. We'll kick things off at the why. Then we'll get our hands dirty building our very first automated pipeline. After that, we'll deploy it to a server the old school way before we dive into the real game changer, Docker. And then we'll wrap it all up into a modern, production-ready workflow. We're going to follow a piece of code all the way from your laptop to the end user.
All right, our journey starts the second that code gets pushed. But instead of a person having to manually check everything, our code now enters what I like to call an automated gauntlet, a pipeline. And its only job is to enforce quality and consistency before that code ever sees the light of day.
Let's break down how this gauntlet works. First, a developer pushes their code. Instantly, automated tools kick in to analyze everything for quality and style. If that looks good, a whole suite of automated tests gets run. And only if every single check passes does the pipeline give the green light to move on. Any failure, at any point, stops the whole process cold. No exceptions.
Okay, check this out. This is the first gate in our gauntlet. This tool, PHP Insights, is automatically scoring our code on things like complexity and style. We can literally tell the pipeline, hey, if the code quality score is less than 90%, you failed to build. End of story. This isn't about someone's opinion anymore. It's about setting a hard, objective, automated quality bar.
But you might be wondering, what about tests that need a database? You can't just run those in a vacuum, right? Well, modern CI platforms like GitHub Actions have an awesome solution for this. We can actually define services, like a MySQL database, right in our pipeline config. It just spins up a temporary, totally clean database just for our tests and then throws it away. This means our tests run in a perfect, predictable environment every single time. Okay, our code made it through the gauntlet. It's been checked, analyzed, and thoroughly tested. Now it's time for the next big step, getting our code out of the pipeline and onto a live server. Now, our server is built on a pretty classic foundation, the LAMP stack. You've got Linux for the OS, Nginx as our web server, MySQL for the database, and of course PHP to run the app. You can think of Nginx as the traffic cop. It gets all the requests from users and passes any PHP stuff over to PHP FPM, which is the thing that actually executes our code. And this right here is the heart of a traditional deployment, a simple shell script. That set-e at the top, that's our safety net. If any command fails, the whole script just stops. Then we pull the latest code, install dependencies, build our front-end stuff, and run database migrations. But look at all the different tools that have to be installed and working perfectly on the server itself. It's a really fragile process, where one tiny difference between your machine and the server can make the whole thing fall apart. So, how does our automated pipeline securely log into the server? I mean, we can't just paste our server password or SSH key right into the script. That's where secrets management comes in. Platforms like GitHub Actions give you a secure vault to store all that sensitive information. Our pipeline can then use these secrets when it runs without ever showing them in the logs or the source code. So that traditional approach, it works. Until it doesn't. And it suffers from a really classic, really frustrating problem.
And that brings us to the next big evolution in our journey, the one that solves one of the oldest problems in software development: containerization with Docker.
And there it is, the 6 most dreaded words in all of software development. But it works on my machine. This is what happens when some tiny difference between your laptop and the production server, like a different PHP version or missing library, causes your perfectly good code to just completely break when it goes live. It's infuriating.
Docker solves this problem with containers. So what's the difference between a container and a virtual machine? Well, think of a VM as building a whole separate house on your property. It's got its own foundation, its own plumbing, everything. It's huge and slow. A container, though, is more like a pre-furnished apartment in an existing building. It just packages up your application and its dependencies, and it shares the building's main infrastructure. The result? Something that's incredibly light, fast, and totally portable. The exact same environment now runs everywhere.
Docker also lets us build in much better security. By default, a container might run as the root superuser, which is like giving your app the keys to the entire kingdom. It's a huge security risk. So, a much better practice is to create a special, non-root user inside the container, just like you see here. This really limits what the application is allowed to do, making sure that even if it gets compromised, it can't do any damage to the server itself.
You know, modern apps aren't just one thing anymore. They're a whole collection of services: an API, a database, a front end, you name it. And that's where Docker Compose comes in. It's basically the conductor for our container orchestra. Using one simple config file, it defines how all these different containers are supposed to start up, talk to each other, and run together as one cohesive application.
Okay, so we've got all the pieces of the puzzle now: an automated pipeline and these awesome portable containers. So let's tie it all together and see what a truly modern, end-to-end production workflow actually looks like.
Now this is where things get really, really efficient. Instead of one long process where everything happens one step at a time, our pipeline can run jobs in parallel. We can build the images for our API and our database at the exact same time. Once they're ready, we run our tests. And if those tests pass, the pipeline kicks off another wave of jobs to build and push everything else we need for production all at once. It's so much faster.
And this is the part that just blows people's minds. With a containerized workflow, your production server doesn't even need your application source code anymore. It doesn't need PHP or Node.js or any of that stuff installed. It only needs 2 things: a Docker Compose file that tells it which pre-built images to run, and an NV file with the production config. The server's only job is to run containers. That's it.
And this right here just brilliantly shows how powerful this is for rollbacks. Okay, disaster strikes. A big bug made it to production. See the image tags here ending in F309? To roll back, all we have to do is change one single line in our .env file to point to the previous image tag, A347, and restart. And that's it. In seconds, the old stable version is back up and running. No complicated scripts, no manual database changes, just pure simplicity.
So there you have it. We've gone from guilty, stressful manual deployments to a fully automated container-based workflow. The whole process is now reliable, it's repeatable, and it's secure. And this frees you from the fear of deploying and gives you back your most valuable resource, your time. So with all that newfound freedom and confidence, the only question left to ask is, what are you going to build next?